Alright, time for the solutions for the solve simple equations number 2. So basically what you need to do is get both of the bases on each side to be the same. On the left side we got 2, on the right side we got 4. Well, that 4 on the right side can just be expressed as 2 squared. And so now we have 2 to the 2x minus 4 equals 2. So you just take these guys here and set them equal to each other. So 2x minus 4 equals 2. So if you have the same bases here, you can just take your exponents and set them equal to each other. So that's where my new equation here, that's where I got it from. You know, just solve it like you normally would, adding 4 to both sides to get the x term by itself, and then you divide by the 2 in front to finish getting the x all by itself, and then the right side is just going to be 3. On 2, you have a base of 4 here, and on the right side you have a base of 6. And so you need to change this to be a base of 4. If you're not quite sure 4 to what power that gives you, you can divide both sides. Divide 64 by 4, and then you'll get 16 here. And divide that by 4. You'll get 3 4s multiplied together. And so the 64 can be expressed as 4 to the 3rd power. And on the left side we got 4 to the 3x minus 3. So since our bases are the same, we can now set our exponents equal to each other. And so now we're looking at 3x minus 3 equals 3. We'll now just solve this one like normal. We need to get our x term by itself, so add 3 to get rid of the subtract 3 term. We have 3x left side, right side 6, divide by the 3 in front of x to get x all by itself, and when you do that you have x equals 2. On number 3, left side we have a base of 2, right side we have a base of 32. We need to split this one into, so it has a base of 2, so I'm going to do 2, and that will give me 16. 16 is 2 times 8, 8 is 2 times 4, and 4 is 2 times 2. So that's 2 to the 5th power, and so my left side there we have 2 to the 3x minus 1, and on the right side we're going to have 2 to the 5th power. So now our bases are the same, and so we can set our exponents equal to each other because they have to be the same. 3x minus 1 equals 5, and now it's just a matter of getting my x all by itself, so I'm going to add 1 to both sides to get rid of the non-x term. 3x equals 6, and divide by 3, and we get the same answer as the previous one, x equals 2. On 4, we have a little bit of a different situation because on the right side we have this fraction, and on the left side we have a base of 3. Well, what you need to do is get this bottom part, express this as a base of 3, and it's going to be 3 to some negative power, some negative number. Well, 81 can be split up. If you divide by 3, you'll get 27. And you divide that by 3, you'll get 9. And divide that by 3, you get 3 again. So we have 3 to the 4th power gives me 81. And so 3 to the negative 4th power would give me 1 over 81. And so now on the left side here, I can go back to my original equation here to get 3 to the negative 3x plus 2 equals 3 to the negative 4th power, because that gives me 1 over 81. And now that my bases are the same, I can set my exponents equal to each other. So I get negative 3x plus 2 equals negative 4. And I'm just going to subtract 2 from both sides because I want to get my x term by itself. And so when you do that, you're going to get negative 3x equals negative 6. And you just divide by that negative 3 in front of the x to get the x all by itself. So now you have x equals 2. Why are all the answers 2? Anyway, on this next one we have a base of 4 on the left and a base of 8 on the right. We need to, if we try to get the right side to be a base of 4, we're going to get 2 as the other number. And so, luckily 4 and all the 4's can be written as a base of 2. And so we're going to have to do that. We have to do a base of 2 on both sides, because 4 can be written as 2 times 2. So in order to do that, on the right side we're just going to have 2 to the third power. But on the left, we're going to have to do 2 to the second, and that 2 up top needs to be times by all this stuff that 4 originally had, which was x minus 3. And so now, in order to solve this, we finally have our equal bases, but our exponentials are there. We're going to set those equal to each other, and you can start solving. So we're going to have 2 times x minus 3, and on the right side we have 3. And you're going to distribute that 2 through to get 2x minus 6 equals 3. And now you're going to solve it like normal, adding 6 to both sides to get 2x equals, what, 9. And then you're going to divide by 2. You'll get x equals 9/2. Alright, moving on to our next one. Again, we have this situation where one side has a base of 2 and the other one has a base of 4. That bore 4 can be written as 2 times 2. And so we're going to switch the base on the left side, making our base now 2, and we have to take our old exponent and times it all by 2 to get our new exponent for our new base. And on the right side, it's still going to be 2 to the 9th. So now our bases are the same on both sides. We're going to set our exponential portion equal to each other. So 2 times x plus 3 equals 9. Now distribute the 2 to get 2x plus 6 equals 9. Subtract that 6 from both sides. And now we're looking at 2x equals 3 and divide by 2. And now we have x equals 3/2. And continue on to number 7. On our left side we have a base of 1/2, and on the right side we have a base of 1/28. Let's turn that 1/28 into a base of 2, because 1/2 and 2 are very similar as regards to exponentials. If you just take 2 and make it have a negative exponent, it'll turn it into a fraction of 1/2 to that positive power. So we're going to take that right side, take 1/28, and divide it into, figure out what it would be with a base of 2. So divide by 2, you get 64. Divide by 2, you'll get 32. Divide by 2, you'll get 16. Divide by 2 to get 8. Divide by 2 to get 4. And divide by 2 again to get 2. So we finally have a lot of 2's. Being multiplied together, it's going to be 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th power gives me 128. If we want it to be, so end up with a fraction there, so 1/2, that would make it so we had a negative exponent there. And so that would give you 1/128 if you had 2 to the negative 7th power. And so what we're trying to get to is we're trying to get, so the right side has a base of 1/2. Well, if you just make that 2 have a power of negative 7, the bottom part is going to be the fraction 1/128, which 1/1/1/128 would just give you positive 128. And so this is what my right side would look like, which is kind of confusing. But right side is going to be 1/2 to the negative 7th. And the left side, you're looking at 1/2 to the 3x plus 5 power. And really you could take this -7 piece and put it outside of the fraction portion, but here it'd be the same thing. And so now we have the same base, and we can finally set our exponents equal to each other to get 3x plus 5 equals -7. And now we can subtract 5 from both sides to get 3x equals -12. And just divide both sides by 3 to get x equals -4. That was kind of confusing. Moving on to the next one, it's looking